Greetings, sir. Today we will be presenting on the topic sentiment analysis on Amazon reviews. These are the team members who have contributed to our project. First, we will move with the introduction of our project. These projects provide understanding of our customer sentiment and classifying product based on their reviews that have become crucial for businesses nowadays. This project represents a valuable application of big data technologies like Apache Spark and machine learning techniques from ML library to analyze customer sentiment in Amazon product reviews. Some of the objectives we have implemented. The first one is ML library algorithm. Machine learning library is a core component of Apache Spark that offers a wide range of machine learning algorithms and tools. And for the Spark integration, it is well known for its ability to handle large scale data processing and analytics efficiently. In order to make an ideal choice for processing and analyzing a large amount of textual data from the Amazon reviews. Lastly, for the classification of the product, the goal of the project is to classify product based on the sentiment analysis of the reviews. By assigning sentiment labels to individual reviews, the project can aggregate the information to detail the overall sentiment of each product. Now Ashish will continue with the presentation.
Coming to the tech stack of this project, Apache Spark is the core engine driving the project. It is designed for big data processing and analytics, makes it well suitable for handling large Amazon review dataset efficiently. Now coming to the Java serves as the programming language for the project. It is known for its portability, reliability, and extensive libraries. The Spark MLlib, which is a machine learning library specifically designed for Apache Spark. It also offers a wide range of tools for scalable machine learning. Now Maven is your build automation tool. It ensures that the project is well structured and handles dependencies efficiently. Maven simplifies the project management and ensures that all required libraries, including Spark and MLlib, are integrated correctly. And next one is GitHub. Coming to the dataset of this project, the dataset is sourced from Snap Standard Network Analysis Project, which consists of a vast collection of Amazon reviews. It is a substantial dataset with a size of around 4.76 GB and consists of a vast collection of Amazon reviews. This dataset comprises of around 11 million rows and includes essential features such as overall ratings, review info, reviewer text, verification status, a summary, and the unique review time. The overall represents the overall rating or sentiments of each review. Review info contains the additional review related details. Reviewer text is the actual content of the reviews. Verified user indicates whether the reviewer is a verified Amazon user or not. The summary provides a concise summary of or the title of each review. Now the Prathamesh will explain about the workflow of the project.
Let's look at the workflow of a project. First step is to initialize Spark context. This component represents the initialization of the Spark context within our Spark application. The Spark context is a fundamental entry point to any Spark functionality. It represents a connection to the Spark cluster and is responsible for coordinating the execution of tasks across the cluster. Next step is to connect with a Spark RDD. An RDD represents a distributed collection of data elements that can be processed in parallel across the Spark cluster. RDDs are the fundamental data abstraction in Spark and serve as the building blocks for Spark applications. Next comes our ML pipeline. The ML pipeline represents a series of data transformations and ML operations that are applied to the Spark RDD. ML pipelines are a way to organize and automate the end-to-end machine learning workflow, ensuring consistency and reproducibility in model development. We will talk more about this in the next slide. Next comes predicted results. This component represents the output of the machine learning model applied to the data. After the ML pipeline has been executed, it produces predictions or results based on the input data. Now let's move on to the next slide and take a look at our ML pipeline. The first component of our pipeline is tokenizer. The tokenizer is the initial step in data pre-processing of ML pipeline. Its primary purpose is to split textual data into individual words or tokens. Tokenization is a crucial step in NLP tasks as it prepares the text data for sentiment analysis. Next comes hashing term frequency. Hashing TF is a feature transformation component that converts a collection of text data into numerical feature vectors. It uses a hashing function to map words or tokens to a fixed number of features or dimensions in a feature vector. Hashing TF is often used when dealing with text data in ML because it allows you to work with higher dimensional data efficiently, reducing memory and computational requirements. Now comes our ML models. We have used two different ML models to further deepen our understanding of Spark. The K-means model represents a machine learning model trained using the K-means clustering algorithm. K-means is an unsupervised learning algorithm that clusters data points into K clusters based on similarity. Logistic regression. Logistic regression is a supervised ML algorithm used for binary classification or multi-class classification tasks. The model predicts the probability of an input belonging to a specific class and assigns the class with the highest probability as the final prediction. Now my friend Vivek will be demonstrating the implementation of a project.
So the code is already hosted on GitHub link, and this is the repo link. Now having a look. Okay, now coming to the project, this is the basic folder structure of any Maven project, and this .maven, .mavenw, .mavenwcmd serve as a Maven wrapper, which can be used on those systems that doesn't have Maven installed. Now let us have a look at pom.xml file, which serves as the file for the dependencies. As you can see, these are the plugins which are used in the Maven for the different life cycles, and these are the modules which are being used by the Java to get integrated with the Spark. We can see the Spark Core version 2.13 followed by Spark SQL followed by mlib. Now let's the main code is stored inside of the src folder, and when compiling, the compiled code is built inside the target folder, which is shown here with the classes. Inside here we have the app.class, which is a compiled version, and after compiling we get a jar file which stands for Java archive. Now let's have a look at the code. In the code, we are using the basic convention for the package, which is com.example, and after that we are importing the necessary libraries. We are importing the k-means clustering SparkML followed by logistic regression approach, which will be showed in the regression approach here. Now after we are creating a Spark configuration using the local as a master, and this line is used for setting up the Spark UI. Now we are initializing a Spark session using the Spark UI, and after running it, we can get the predicted results. As Prathamesh explained, hashing FT and tokenizers are being used in our ML pipeline to convert the data into one hot encoding, and we are using the number of clusters for k-means as 5. And let's have a look at the results. To run this, we are using command mvn exec java. This Java lifecycle is defined in the pom.xml file here. Here inside the build plugin, we are explaining it the Java lifecycle. As you can see now, the Spark is initiated and it's sharding our dataset into these many tasks, and the Spark UI is also being generated. Here we can see the different jobs. Like right now, one job is started with 38 subprocesses in it. After completing, we can get results something like this. This is the loaded. Okay, sorry, let me continue presenting. So this is the loaded RDD, which is printed afterwards after the complete loading phase, and these are the predicted results of k-means clustering. As you can see, we have the product ID here followed by the clusters to which they are belonging to, and this is the Spark UI's jobs module.
Now for the further improvement part, first we will be getting into Spark clustering. Spark clustering based algorithms is to identify patterns and groups similar to products of review together. Clustering can provide valuable insights by uncovering hidden trends and segments within the data. Second will be the NLP integration, which will provide us accurate summary of reviews by integrating more advanced natural language processing techniques and models. Lastly, we will be able to create a live portal for user input using web app. The web app can serve as an interactive platform for consumers, businesses and researchers. Now Vivek will continue with the presentation.
Now the challenges which we faced during the setup of the project and running the project was, one was that setting up the environment, and in this the major challenge which we faced were like we were unfamiliar with the Maven compilation, like different life cycles. and that was a major problem with us. And since the data set was around 4.74 GB, the clean phase was a big issue, and the resource management was also a big issue for us. As I said, no, we thought of implementing clustering, but we had faced with the SSH config errors. And last but not least, since Java was a new language for us, it became a big challenge for us, so we had to learn Java and implement all this. With this, we conclude our presentation. Thank you.